I'm Dr. Benjamin Wolfe. I'm an assistant professor here at UTM Psychology, and I'm a co-director of the Applied Perception and Psychophysics Lab. The Apply Lab studies visual perception very broadly. We study everything from fundamental mechanisms of how we see the world all the way to applied questions in driving and reading. I grew up in Massachusetts in the United States. I actually got my start doing research in high school, where I had the opportunity to work in a lab that really focused on aspects of technology. I then, as an undergraduate at Boston University, actually spent 3 years in the lab that did models of stroke and visual attention. After that, went on to a post-bac position at Vanderbilt University in a working memory lab where I gained some experience with fMRI. I went on after that to do my PhD at the University of California, Berkeley. Really focused my training in vision science and mechanisms of vision. After completing my PhD in 2015, I moved to MIT, where I did 2 postdocs. I was a postdoc for a year in a human factors lab. Human factors is the intersection of psychology and engineering. It's really what do designs need to bear in mind about people. And then I spent an additional 4.5 years in a lab that spanned the Computer Science and Artificial Intelligence Laboratory at MIT and the Department of Brain and Cognitive Sciences, where I really sort of developed my own research program sitting at the intersection of fundamental vision science and human factors. I joined the faculty here at UTM in 2021. That's really where my research sits. I've gone from just being interested in the technology to being interested in vision science to really bridging the two of them together in the work that I do now. I've always been really nerdy. I've always loved technology. I've always loved the gadgets that we work with or use. And research gave me a way to actually use that and start answering really interesting questions. I went into vision research particularly because I found the questions really interesting. How do we get the information we need to move through the world, to exist in a visual environment? But also because, frankly, it gave me an opportunity to use the gadgets that I really enjoy. I grew up around research and around vision science as a field, but finding my own questions within that was something of a challenge, in finding this intersection of real-world problems and technologies has really become what I do, and it lets me parlay that early passion for technology itself into a broad suite of questions and problems. Vision science is an incredibly large area of psychology. In fact, it's where a great deal of the history of psychology comes from. It comes from people trying to study and systematize how we perceive the world going back to the 19th century. So that's an incredibly large space to operate in. And the pieces that I'm interested in, which are things like visual attention and peripheral vision, so how do we look for things that we're trying to find in the world? How do we perceive the world around not just where we're looking, but all of the visual input we have? That really comes out of an interest in how do we use vision in the world, as opposed to just, vision in laboratory experiments, which generally don't look much like the world. And I wanted to do research that actually had an impact. And so that's really what pushed me towards what I call use-inspired problems. So that's where we look to the world for questions that vision science can help answer. We bring them into the lab, we study them using the tools and techniques of vision science, and then we convey the answers back to people in the world who will actually use them. We want to learn something that helps the world more generally. Really being able to find answers to real questions and do that in a way that actually doesn't just answer, we need to know how to build this thing right now, but in a way that actually increases our knowledge of how vision works, how cognition works. It really helps us understand the mind and the brain. The hardest part of research is that lots and lots of things don't work. If I design an experiment or come up with a theory or an idea, odds are it's going to fail. It's going to fail in a probably hard to understand, confusing, frustrating way, and that's just part of doing research. You're never going to come up with the perfect, unified, never-changing theory of vision or perception or really any process you can think of. And being okay with being wrong is one of the hardest parts. Research is full of hard tasks, whether it's programming or statistics or building equipment, and everyone's going to find some task that doesn't come to them easily. And my advice is it will serve you better down the road, whether you are going off to grad school or becoming a professor or going into industry or anything, to really have a broad set of really well-established skills. For example, if statistics are not something that you enjoy, very few people do, you should really still dive into that because it's a very important and useful skill set. The other piece of advice for Ben of the past would be focusing on depth in particular areas is remarkably important. It's very tempting, particularly when you're starting out, to say, I'm going to do this, I'm going to do this, I'm going to do this other thing. That's really not great either for your own development as a scientist or for your ability to move to the next steps. So potentially staying in one lab, focusing on one set of questions and skills gives you a deeper base on which to build and eventually broaden from, as opposed to flitting between different projects in different areas. Probably quite recently being able to take students of my own to international conferences that I've been going to since I was a postbac. I got to take them to that conference, see some of them present to people who have watched me come up as a scientist and as a scholar. I'm now getting to introduce my own students to that community, and a community that I really value and that I really appreciate and that I really trust. And being able to see that, that makes me really proud. I can mentor and support and train students in the way that I was mentored and supported and trained. My long-term goals are to really keep training new scholars. I really want vision science to have a broader view, not just in terms of the research questions, but who asks them. So I really want to see people come into vision science who haven't just taken, say, a cognitive track in psychology, but I want people coming in from very different perspectives, whether that's in psychology or outside of it, to say, hey, there's a lot of tools and techniques and ideas here that can speak to the world. And so I want to spend the rest of my career asking questions about the world, doing that with a variety of trainees and collaborators and scholars, and really trying to have an impact beyond just, oh, hey, we found something, we wrote another paper, and it's going to be read by 3 people on the planet. My goal is have an impact. I don't need to, turn that into, I'm going to build, a company or a startup or something. I just want this to be work that actually goes out into the world and that maybe someone else can use to make the world better.